Welcome back, guys. JC here, and here's the very long-awaited how to install a current sensor and calibrate it and get everything working. I'm not gonna lie, guys, I've been avoiding this video for months, hoping that you would forget about it, but you haven't. The reason I've been avoiding it, and the reason there really aren't that many videos on how to do this, is because it is a royal pain in the ass. It's a lot of work. You still have to calibrate it at the end, and that is actually the hardest part of the entire procedure. And if you don't calibrate it correctly, then really there's no point in even having the current sensor at all. It's pretty much useless. I will go ahead and say, and I say this in many of my videos, in this hobby there is like 5 different ways of doing the same thing. I am going to show you my way. If you don't like my way, then don't do it my way. So there's a fair warning. Please don't tell me I'm doing this the wrong way. There's many ways of doing the same thing. As far as what do you need to purchase, there are 2 main ways of getting a current sensor into your build. You can use a PDB that has a current sensor built in, or there are also these larger modules that are actually separate, and they tie in between your LiPo battery and your normal PDB. I don't recommend those because they are so large. The only time I would ever consider using those are for a very large multi-rotor, like a hexacopter or octocopter, like a 600mm frame or above, because they're really not going to fit on these builds. So on these types of builds, we are pretty much limited to PDBs with them built in. Now, which PDB do you need? What do I recommend? I'm actually not going to recommend one to you because there are so many. You'll just have to do your research and figure out which one do you like best. The reason I say it is because not only do these PDBs, some of them have current sensors built in, they also have other features. Some of them have the 4-in-1 ESC ports. Some of them have 5-volt BECs and 12-volt BECs built in. Some of them have a 5-volt BEC and an adjustable BEC built in, to where you can just turn this screw and you can choose the voltage that you want on the adjustable pins. Some have LC filters built in, some have on-screen displays built in. So that's why I say you will have to pick one on your own. So I have picked the PDB that is best suited for my personal build. Now, as far as how to install it, it actually installs just like any other PDB. You just run your ESC main power and ground wires to the PDB like you would any other PDB. If yours has the 4-in-1 ESC port, then you would run these the signal and ground wire to here as well. Or if you don't have that feature, then you will just run this to your flight controller. But it's the same thing, so let me go ahead and do that, and I'll be right back. Okay, now I have my PDB installed with all my ESCs soldered to it. Now let's talk about how we run the current sensor wire. A lot of these PDBs use, I don't know if it's called an APM module or APM connector, but it's a connector that looks like this. Here's a better view. And you're going to have 2 grounds, 2 5-volt power sources, and then a current sensor and voltage sensor. If your flight controller does not have a built-in BEC and you need 5 volts to power it, you can use this connector. Although this PDB actually has 1, 2, 3 5-volt power sources on it. And then same thing for this one, it has 3 5-volt pins. But like I was saying, you can use that to power your flight controller. Now if you're using a flight controller that has a built-in BEC, like the Omnibus, the Seriously Dodo, the Seriously Pro Racing Mini, or any flight controller of that type, you are not going to use 5 volts to power it because, like I said in many videos, the way you power these is with the full voltage of the battery. So you would just take a couple wires and solder those anywhere on the PDB where it's getting the full voltage of the battery, and then put these onto the flight controller wherever that may be on the power and ground pins. The reason you don't want to use any 5-volt power sources on those types of flight controllers is because it will power it and everything will work, but you will only see 5 volts in your telemetry and on-screen display. Long story short, because I am not using either one of these 5-volt pins or the grounds that go to them, I'm going to actually depin those wires from this connector because I don't need it. For the voltage sensor wire, you can also depin that because you more than likely don't need it. These flight controllers with the built-in BECs, they detect the voltage through the power and ground wires automatically. And then on flight controllers that don't have that, they usually have separate VBAT pins. So you will just run the full voltage of the battery to those separate VBAT pins to get voltage in your telemetry and on-screen display. Therefore, this is not needed for anybody really. So the only wire I will be using is the C-Sense wire, which is current sensor. To remove the wires from this connector, I'm just going to grab one wire at a time and pull on it with one finger while I'm holding it in place with the other fingers. Then stick my razor blade underneath this little tab, lift the tab up, and pull the wire out. Just like that. And then I will do that for the rest of the wires. And that will give me something that looks like this, just a connector with one wire on it. Also, all these wires that you removed with these little connectors, you can actually keep these for later. They come in very handy. So I'm just going to plug this in, just like that. Now for the other end, if you are using pins on your flight controller, you can plug this in to where your current sensor pin is. But because I don't use pins, I just solder my wires directly to the flight controller. So I will actually find the length of wire that I need, cut it, and solder it onto the current sensor pin. Now you're thinking, JC, what are we about to do? Did I mention how dangerous calibrating current sensors are? And that is just one more reason why I hate doing this. So what we have going on here is, first, with nothing in the way, I went ahead and tied this rope around my table. I recommend doing this outside if you can, if you have a laptop. If you only have a desktop, then I don't know what to tell you. But you are all adults, so I'm going to trust you to not kill yourself. Just be very, very careful with this. Like, I can't stress this enough. This is extremely dangerous. Back to what I was saying. I took some rope, tied it to the table, and I got it as tight as I could because it does, slightly bend. I then slid the multi-rotor underneath both ends of the rope, and then I put a box underneath the multi-rotor just to get rid of any extra slack. So now it's pretty secure. If you think it's still a little slack, if you can pick it up off the table, then put more stuff underneath it. Just keep putting stuff underneath it until it feels very tight and it's not going anywhere. You do have to have your propellers on to do this part because you can spin the motors, but without propellers, the motors, there's not a real load on the motors. Without a real load, your amperage is not going to be correct. It's not going to be as high as you need it to be. So if you were to calibrate your current with no propellers on, it's going to be inaccurate. But we need an accurate reading of the current so we can make what we see in Betaflight match what the actual current is. To do that, you need some type of ammeter, like, if I said that right, I'm sure someone's going to correct me, but you need something like this that can read your amperage. I got this off of Amazon a very long time ago. I can't remember how much it cost or where I got it from, but I'm sure you can find it. It's rated for up to 130 amps, which is more than enough than what we need. It did not come with these XT60 connectors on it. You will need male and female, so be aware of that. But basically, we are going to plug this into the multi-rotor. I'll flip this around. And then we can take a battery and plug it into the other side. By the way, when you solder your XT60 connectors onto these things, make sure it's going in the right way. You can see where it says source and load. So source is going to be where you plug your battery in. Load will be on the side that the multi-rotor is on. Now I'm going to try to fix this on the meter so you guys can watch that as I do this. And you can also look at my Betaflight configurator at the same time. So right off the bat, before we even start, the meter is not matched up to what Betaflight is showing. The meter is correct, Betaflight is wrong, so we need to make some adjustments. As far as explaining to you guys how to do this, I really can't. This is really just completely trial and error. I will give you what little tips I do have though. So I am actually going to start off by scaling the output voltage. I will get to the offset next. So even though our numbers are not perfectly matching right now, I mean, we're only talking like half it or 1 amp. So if we turn our motors on,
things are about to get real.
Very slightly. Okay, so you saw how we started off with only 1 amp of difference, but as we sped up a little bit, we saw 3 amps of difference. Then when we sped up again, we saw 5 amps of difference. And the more you increase the throttle, the more it's going to become further off from what the actual current is. And that is why we need to scale it. I'm just completely guessing here. There is no theory behind my madness. Like I said, it is completely trial and error. Okay, so let's try it again and see if our results got any better.
Things are about to get real.
That is better, but we still have a long ways to go. I'm actually going to touch on the offset slightly. Well, that is going to be that, guys. I feel as if that's close enough for me and my standards. Everyone's different. You can keep going to get it absolutely perfect. Just know that you'll be doing this for a while. It all just comes down to how much time do you want to spend on it. That's going to do it, guys. So I hope I explained this fairly well. I know you guys have been waiting months for me to make this video, so I hope some of you are pleased. But that does it for now. So if you have any questions, leave it for me in the comment box. Thanks for watching. Take it easy. I'll see you next time.